Hello friends, in this video I am going to talk about my new GPS tracker design. This is the second version. Earlier I had designed one more version which I had manufactured almost like an year back, and I had kept the device for testing in my motorcycle for around 6 months. In 6 months of use, I noted a few things which needed improvement. The first point is the tracker was always turned on and it was continuously sending data to the server at 1 minute intervals. And because of this, the battery of the vehicle got drained continuously and it was not able to get charged again. Because of deep discharge, I had to replace this battery in 6 months. And also the earlier version was designed to be a personal tracker. It was not designed to be a vehicle tracker, so it could take only 4 volt input, and the vehicle battery is supplying 12 volts, so I put a breakout board which converted 12 volts to 4 volts for the tracker operation. Also, the first version did not have support for any kind of ignition control. So what's new in second version? In the second version, I added a motion sensor which can be used to detect the vehicle motion and activate the GSM module and send data or location information to the server. Whenever there is no motion or when the vehicle is standing idle, the GSM module can be turned off and save battery power. Because GSM module is the one which consumes most of the power in the circuit. If we keep GSM module off for most of the time, we are going to save a lot of battery power. In the second version, I also added a 12 volt battery charger which can take in 12 volt directly from the vehicle's battery and supply 4 volts to the tracker circuitry, and it can also meanwhile charge the internal battery which can be used for emergency purposes whenever the main battery is disconnected. Suppose if your vehicle gets stolen and if the main battery is disconnected, then your tracker becomes dysfunctional and it cannot send location information to the server or to the owner. So if we have an internal battery, it can be used to keep the tracker alive and keep sending information to the server whenever there is a disconnection of the main battery. In the second version, I also added a USB connector. This USB connector can be used to charge the internal battery whenever this device is used as a personal tracker. This USB connector can also be used to program the onboard controller, because I have routed the SWD lines of the ARM controller to the USB connector. So using this USB connector, you can easily write your own program and dump to the microcontroller and test this device using your own custom code. I also added a 2 megabits of EEPROM, which turns out to be around 256 kilobytes, and this can be used to save GPS data whenever there is no GSM signal available. This EEPROM can also be used for firmware update over the air, wherein you can download and save the firmware file from the server into the EEPROM and program it later to your microcontroller memory. An emergency switch or an SOS switch has been added in the second version, which can be used to contact family or friends in case of emergencies. So whenever this switch is pressed, an SMS or a call is sent to the pre-programmed emergency numbers. In the second version, there will be Bluetooth support, using which we can develop a mobile application for changing or modifying APN values, IP addresses, port numbers, or server URLs, and we can also modify the emergency contact numbers for SOS option. The microcontroller which was present in the first version was a simple microcontroller. In the second version, the microcontroller is changed to a QFN package microcontroller to save some space, and we also change the microcontroller to a low power device. So these are the main features available in the second version. In the future, we can develop open source software which can send data to different cloud platforms like AWS, Google, or Carriers or IBM. I also have plans wherein we can remove the GSM module and put a LoRa device on place of it and use it for intra-city GPS tracking, wherein we can track courier delivery vehicles or pizza delivery vehicles, or we can even track our elders who go for a morning walk. Using LoRa network, we can track any device which operates within intra-city limits. Also, right now the device is sending data to the server using HTTP protocol. Maybe in the future we can develop MQTT protocol over TCP for sending data to different cloud IoT servers, because most of the IoT platforms use MQTT standard as default. Right now the status of the product is the design is almost complete, and I have sent the boards for fabrication, and I'm waiting for the boards to arrive in this week. Once the boards arrive, I'm going to order some components from Mozo.com and some of the parts locally, and later on we are going to assemble the boards and do some basic software development and board testing. And once everything is frozen and we are confident that the product is stable, we are going to start selling the device. Currently, I estimate the device price to be around rupees 3,500 to rupees 4,000, and it might even go low once we do mass production. One more thing I wanted to mention was Right now I'm using a ready-made enclosure for this device, and maybe in future I want to get a custom enclosure done so that it can be made waterproof and can be protected from different environment conditions. But getting a custom enclosure done is expensive because of plastic molding. So until I get enough funds, I'm going to put the custom enclosure design on hold. If you are asking why did I design this product, I designed this product because most of the GPS trackers available today are all Chinese GPS trackers, and these are all closed designs. Means if anything goes wrong in these devices, then it's very difficult to find replacement parts for these devices locally. And that's why I want to keep this design as open as possible so that the device can be easily repaired or the parts can be easily replaced whenever the device goes bad. And I also found that most of the Chinese GPS devices are hard-coded to send data to their own servers, and we cannot configure them to send data to our own servers. So using the Bluetooth feature, we can develop a mobile application which can set all the configuration parameters including the APN values, IP addresses and server URLs. I also forgot to tell about the size of the device. Right now, according to the current design, the PCB size is around 52 mm by 18 mm. This is the PCB of the first version. This was around 52 mm by 20 mm. It was made to be fit in this enclosure, which is of the size of around 52 mm by 25 mm. You can look at it. So this will be the size of your GPS device once it gets ready. I also found this battery which kind of fits correctly into my enclosure. This is a lithium battery of the capacity of around 2500 mAh, and it fits correctly into my enclosure. So this is how the product is going to look after the PCB and the batteries are inserted. The PCB in the current version is much smaller than this PCB by around 2 mm. This enclosure will have the 2500 mAh lithium battery as well as the GPS tracker PCB in it. Two wires will come out of this like they have come out now, and it will also have a USB connector on it. You can also remove the board and charge the internal battery using a USB charger. And if you are interested in this product and you want to receive updates about the development that's going on, then you can stay in touch by subscribing to my YouTube channel, or you can subscribe to my newsletter on my blog www.raviyp.com, or you can drop me a mail at ravi@valetron.com, and I will make sure that you receive all the updates that's going on. And if you want to make any contribution to this product, there are different contribution options I have mentioned on my blog. Do have a look at it. Thank you for watching.